Hi students, welcome back. Under the subject Algebra and Number Theory, we are into unit number 2, Finite Fields and Polynomials. The topic for discussion is Division Algorithm. It's part 2. So let's get into the PPT. Now, this is my fourth lecture. I'll just have a recap or brush up over my previous lectures. In the first lecture video, I had introduced what is a polynomial and how to find the degrees of the polynomial. Then, based on the finding the roots of the polynomial, we had discussed in under lecture 2. So how do I say a particular element is a root of a polynomial? Suppose if I declare a is a root of a polynomial f of x, then f of a is equal to 0. That is, my answer should be 0. That is, there shouldn't be no reminders. This is what the definition of a root of a polynomial says. So root of a polynomial, when a quadratic equation is given, it's very easy for us to just equate it to 0 and get the roots. Whereas if a modulo arithmetic when we are using, then we got to find out whether that particular answer or particular that number is divisible by that particular modulo. And then if the remainder is 0, then we can call that particular element as a root, or else it is not a root. Okay. And in my third video, we had started what is a division algorithm. So division algorithm, I guess many of you know that. Who had given the came up with the division algorithm? Whose work was it? It was by the great mathematician Euclid. So he was the one who has introduced HCF, and in a very earlier stage, and you guys already know what is HCF is. So now we are the extension of this HCF and the common factors division only comes under division algorithm. So let f of x is equal to 0 and g of x be two polynomials in f of x. So now we are going to consider two polynomials, f of x and g of x, in capital F of x. Then there exists a unique polynomials q of x and r of x belonging to capital F of x such that g of x is equal to q of x into f of x plus r of x. So q of x is the dividend, that is the term which is going to be divided, and f of x is the divisor, the term which is going to divide. So the divisor should be strictly not equal to 0. So what happens if it is equal to 0? If it is equal to 0, the entire term will be undefined. So that is a restriction done here. So necessarily the divisor should not be equal to 0. And here, how am I writing the dividend here? The dividend is equal to the product of the quotient plus the divisor plus the remainder. Okay. Now, r of x is the remainder, q of x is the quotient. And another additional thing which is told about r of x is can be equal to 0. That is, a remainder can be equal to 0. It can happen because 6, when I'm dividing by 6, it's going to be, the remainder is 0. So the degree of r of x should be strictly less than degree of f of x. So that is, f of x is the what? Divisor. So the divisor's degree should always be greater than the reminder's degree. Is that clear? So this is the just a recap of your division algorithm framed by Euclid, the great mathematician. So let's get into the problems. So we'll start with problem number 1. F of x is equal to a fourth degree polynomial and g of x is a second degree polynomial, and we got to determine what is the quotient and the remainder in modulo 7. So when f of x is divided by g of x, it's an analytic equation. So first we'll start with declaring what is f of x and g of x. We have two polynomials. As I told you, the divisor polynomial should be greater than 0 because of division algorithm. So now how do I write modulo 7? Modulo 7 is starting from 0 and ending at 6. So totally you should have 7 terms here. So it starts from 0 and ends up at 6. It's a field. So how do I find the quotient and the remainder? It is as same as we have done in the previous lectures. So we use long division method. We are going to keep addition and multiplication done under modulo 7. So put up the higher degree term inside. Okay. So divide that, and then what do I do here? Dividing this, it is going to be this is 30x square. So there's an error. 30x square x power 4 plus 5x square plus 2. When I take this 30x square and divide it by 6x square, it will be getting 5x square there. So 5x square. So when I multiply 5x square into 6x square, I'll be getting 30x power 4. I had written it here, but you should not write it there. Why? Because your answer is 30x power 4, but the number which is greater than 7. So here we are performing modulo division. So perfectly we got to see that whether how many times, whether are we getting a remainder when we divide this 30 by 7 or we don't get a remainder. So what is the answer when I divide 30 upon 7? 7 4s are 28. And what is the remainder? So this is 2. This is the remainder. So that 2 have to be written here. Okay. No issues if you write 30 also. After writing 30, you can correct it and put the division modulo answer, remainder. Now coming back here, it is going to be 5 into 4 will be 20, right? 20x square. So 20 again a number greater than 7. So when I'm going to divide that by 7, right? 7 2s are 14. So the remainder is 6. So that 6 is done here. Is that clear? So always put up the remainder for this. Now for what will you do when a number is less than that? The next question arises. Suppose if I have a number, say 4x square, what should I do? 4 is less than 7. So need not to do anything about it. Either you can convert it as a negative term or just leave it. No issues in that. That's not going to affect the problem. But make sure the numbers which are greater than that particular modulo what we are considering in that particular problem should be necessarily divided, and the remainder has to be put up there. So now changing the sign, etc. So now again you go for the next next element divided, and you get the quotient and the remainder. This is the division algorithm, says that this is called the dividend. Dividend is equal to the product of the quotient into the divisor plus the remainder. So we move on to the next problem. Problem number 2. Now it is given as a fifth degree polynomial. And now see, it is divided by x minus 1. It's a linear polynomial. Find the quotient and the remainder under the modulo z of 5. So f of x is equal to fifth degree polynomial and g of x is equal to x minus 1. Since I will write z5. So z5 is written as 0, 1, 2, 3, 4 is a field. To find the quotient and the remainder in z5, we perform long division when f of x is divided by g of x, keeping in mind the addition and multiplication under modulo 5. So first you put up the entire big term over there inside, and you put up with the linear equations x minus 1. So how will I start my division? Take this x power 5 and divide this by x. So you'll get x power 4. Put up this x power 4 on my numerator, on the quotient. Take that x power 4 and multiply this. It's going to be x power 5 minus x power 4. So change the sign. So the coefficients are 1. So need not to worry about it. Change the sign and this will get cancelled. And if I want to change the sign, it's going to be 3 plus 1. It's going to give you 4x power 4. And bring down this x cube. So it's going to be 4x power 4 plus x cube. Got it? Now again take this 4x power 4 divided upon x. So you will be landing up with 4x cube. So that is here. So I'm repeating. Since I've changed the sign, I'm getting 4 and adding these two. I'm getting 4x power 4. Now dividing this 4x power 4 by x. I'll be getting 4x cube. So that I've written in the quotient term. So 4x cube multiplied by this x minus 1. I'll be getting 4x power 4 minus 4x cube. So again changing the sign, these two will get cancelled. Again this becomes plus here. So adding these two, I'll be resulting with 5. Correct? 5x cube. But what happened to this 5 here? I couldn't see any 5. What has happened to the 5 here? Yes, since it is performed under modulo 5, I had to divide that 5 upon 5. right? So there is one time, there is no other reminder. So just put up there. So that reminder term alone will be there, right? So reminder is not there. So just leave it. So it's just going to be x square. Bring down. This is going to be 0, right? So this entire x cube plus 5x cube, that is going to be reminder is going to be 0. So that term will just and bring down this x square and 2x and divide this x square upon x. You get x. Put it here. Again take this x and multiply with this and you get x square minus x. Right? So you will be changing the sign, cancelling out this x square, changing the sign, you will be getting 3x. And now the last number, bring down this 2. So you get 3x plus 2. So here I am not using the modular division because this 3 is less than 5. No need. So now again taking this 3x, since we see the power of the divisor and this 3x is same. So we need to continue. So divide this 3x upon x. I'll be getting 3. So plus 3 I put it up here. But take this plus 3 and multiply to the divisor. I'll be getting 3x minus 3. Changing the sign, 3x and 3x will get cancelled and my answer will be 5 here, right? Because minus 3 will become plus 3 when I change the sign, and plus 2 and plus 3 will be getting plus 5. So 5 is not allowed since you are doing in the modulo 5. So what is the remainder? 0. Very simple problem. And what is the quotient now? X power 4 plus 4x cube plus x plus 3, and r of x is 0. That is, there is no remainder for us because of the modulo happening. And this using division algorithm, how will you write? This f of x, that is x power 5 plus 3x power 4 plus x cube plus x square plus 2x plus 2 will be equal to x minus 1 multiplied by the quotient x power 4 plus 4x cube plus x plus 3 plus the remainder. So since the remainder is 0, so there is no need to write the remainder. Just leave it. So multiply these two, you will get this polynomial. That is the actual. You can even try multiplying the divisor and the quotient and just check. You can divide and you'll be arriving at the term which is inside the division symbol. So I guess you understood this problem. So we move on to the last problem. So now this is another approach of polynomials. Now what they have done here is they have given f of x. There is only one polynomial given and they've asked you to do write this polynomial as a product of first degree polynomials. Try to understand. They're asking this polynomial, a third degree polynomial, to be written as a product of first degree polynomials. So what is first degree polynomials? They are linear equations. So how to write linear, how to get the linear equations? You have to find only by through the roots of that particular polynomial. So for that, since z7 is mentioned, you got to write down all the elements of z7. So starting from 0 and ending at 6. So f of x is equal to this. So how do I find the roots? So I'll start substituting one value after the other. So if I substitute 0, what is the answer I'm getting? 0, 0, 0 and 6. So I'll just check out. 6 is a number which is less than 7. So there is, even if I perform modulo addition, it is not equal to 0. Or why have they written minus 1? A small introduction about this. Because why minus 1 here? Minus 1 in the sense, it is minus 1 short of 7. Able to understand? Since 6 is less than 7, then we say how many less than that of that? Short of that. So it will be minus 1. So even though whatever you're writing in negative also, there's no worries. So it is not equal to 0. So now next number is 1. If I substitute 1, my answer is 14. And if 14 is greater than 7, so if I'm going to divide 14 upon 7, my remainder is 0. So automatically what number I substituted? 1 I substituted, right? So what do? Therefore 1 is a root. So immediately after saying 1 is a root, can I write x minus 1 as a factor? Yes, of course I can. So for example, 1 is a root. If a is a root, x minus a is a factor. So I got one factor here. Let me move on to the next number. Now I'm moving on to the number 2. So for 2 I will check. The answer I'm getting it as 38. 38 is greater than 7, and if I'm going to check the modulo for it, 38 in the sense which is the closest number. 38, you get 7 5s are 35, right? So 7 5s are 35 and remainder is 3. So which is not equal to 0. So I leave out 2. Let me go for 3. 3 if I substitute, my answer is 84 and it's perfectly divided by, it is divisible by 7. So what do I do? The remainder is 0. So 3 is the root. If I say 3 is a root, I can extend that by saying x minus 3 is a factor. Is that clear? So when a number is a root, x minus that root will be a factor. So for similar way, I will be checking what is for f of 4. F of 4, if I substitute, my answer is 128. So 128 is not directly divisible by 7. So you get a remainder 2 which is not equal to 0. So I omit 4. So I'll go for 5 now. So if I'm going for 5, my answer is 266. 266 is perfectly divided by 7 and you get a remainder 0. So therefore I say 5 is the root. 5 is the root of f of x. And so x minus 5 is a factor of f of x. Is that clear? Right. So how many roots so far we had got? We had got one root. 1 as a root, 3 as a root, 5 as a root. So still remaining 6 is remaining. So let's substitute 6 over there. So if I substitute 6 over there, my answer is 414. So if I'm going to divide 414, this you can use your calculators and divide this 414 upon 7. You see that if it is perfectly dividing means you will be getting a whole number as your answer. If you're getting some decimal number as your answer, for example 5.5 or something like that, then it is not perfectly divisible. You can say like that. So it is, my remainder is 1. So how many times it's going? The remainder is 1. So 6 is not a root. So since we have 3 roots here, as I told, the extension of these 3 roots can be made as factors. X minus 1 is a factor, x minus 3 is a factor, x minus 5 is a factor. So what was the question about? They're asking to write this f of x in a product of first degree polynomials. So we got to write the product of these 3 polynomials. So x minus 1, that's the first factor, x minus 3 is the second factor, x minus 5 is the third factor, which is equal to f of x in Z7. So you have to clearly mention under which modulo you are performing this entire finding the roots and the factors, etc. So this is another important type where you're given one single polynomial and you're asked to represent that particular polynomial as a product of first degree polynomials. Means the best way to handle up this problem will be going and finding the roots and finding the factors through the roots and putting it as in the product way. Okay. So thank you so much. A small recap what we have done in my 4 lectures. I guess you had understood this video. So first thing, introduction to polynomials, degree of polynomials. Then you have roots and factors of polynomials. Then division algorithm by the famous mathematician Euclid. And then division algorithm using modulo division, how we introduce, how we wrote the remainder. So make sure if a number, the answer what you are getting is greater than the modular number, definitely you got to divide it and you have to write down the remainder. Suppose if the remainder is equal to 0, you got to omit that particular term. Okay. So thanks for watching the video. We'll move on to the next video in the next session. Thank you so much.